Okay, welcome to topic 8.2. So 8.2 you'll be talking about angle of elevation and depression. So what is angle of elevation and depression? Okay, let's say I have a mountain. Okay, and then I am standing on the mountain. Okay, when I look straight, this is my horizontal line. Okay, horizontal line. Okay, let's say I am looking at a cloud. Okay, around here. Okay, when I look up, I'll have this as my line of sight. Okay, so angle of elevation is actually just the angle of the horizontal line to this line of sight that I have, for example. So this is just angle of elevation. Okay. Next, I have my angle of depression. So angle of depression, let's say I see a building below, far away. Okay. Maybe, I don't know, I see Marina Bay Sand or something. Okay. So I look down. Okay. And then this angle between the horizontal line and my line of sight is my angle of depression. So how I remember them is when I go home. Okay, I'll just write it down. When I go home, yeah, I take the elevator. Take the elevator up to my house. Okay, over here you have your elevate. Okay, so angle of elevation, it is going up. And then for angle of depression, okay, when I am depressed. Okay, for those who don't know what's depressed, it just means sad. Okay, I look down. Okay, so I just look down when I'm sad. That's how I remember depression is downwards. So angle of depression is from horizontal line to when I look down. Okay. So in class, if you all pay attention to what Mr. Chiang say, let's say this cloud, somehow there's someone on the cloud. Okay. And then this is the horizontal line. Okay, when he looked down, his angle of depression, okay, is actually the same as my angle. Okay, this person B, this person A. So the person B angle of depression is actually angle A, angle of elevation. Why? Because if I follow this green color line, do you see that I form a Z shape? So I can use alternate angle. Okay. Similarly, let's say someone is at Marina Bay Sand. Okay, so this person C. Okay, when the person C look up, let's say this is the horizontal line. His angle of elevation is over here. So angle of elevation of person C is actually the same angle as my angle of depression of person A. Okay, why? Same thing. I can form a Z shape over here. So now I use red color. Okay. So depending on perspective, but your angle of elevation can be the same as angle of depression. Okay. So actually, this is all you need to know for this topic. Okay, I'll move on to some example. for us to try. Okay, so let's try example 1. Example 1. So a point on the ground is 100 meter in front of a building TB. Okay, 100 meter. The angle of elevation to the top T of building is from A. Okay, so from A again. Same thing as the previous topic. You need to know where it is from. Okay, it's 39 degree. Okay, find the height of the building. Okay, so over here actually it's just 90 degree. Okay, so I can use my Tokaso. So sine 39 equals to O over, oh sorry, not sine. I have my O, I have my adjacent, so I have tangent 39 equals to TB over adjacent 100. Okay, what I'll get, I bring my 100 to the other side, I'll get TB equals to 100 tangent 39. Okay, which will give me 81.0 meter. Okay, so actually this one is a rounded off value. Okay, the actual value is probably something like 80, sorry, it is 80.978. Okay, then I round off to 3SF, I get 81. Okay, for part example 2. Okay, the diagram, TQ is a building height 80 meters. The angle depression of a car from the top is 40 degree. Okay, so this part at the top is 40 degree. Okay, find the distance between P and Q. So they want me to find this. Okay, so actually I have two ways for you. Yeah, I'm gonna do the blue color one first. So by using alternate angle, let me find my highlighter. Okay, you can use alternate angle first. So my angle of elevation is the same as the angle of depression. Okay, angle TP. Is this P or R? P. Okay, TPQ equals to 40 degrees. Okay, then tangent 40. Okay, why tangent? Because this is, I have my opposite. I want to find my adjacent. Okay, which is PQ. So tangent 40 equals to O. So it's 80 over adjacent. Adjacent is my PQ. Yeah, I bring my PQ over. And then I bring my tangent 40 over to the bottom. So I get 80 over tangent 40. Okay, this will give me 95.340. I round off, it will be 95.3 meter. So this is 3SF. Okay, I can also use another way to find my angle PTQ. So PTQ is actually just PTQ is actually 90 degree minus 40 degrees. This will give me 50 degrees. So now using the red one, I need to find what is my O. I have my adjacent. So same thing, it will be tangent. But this time my angle is 50 degree. Okay, tangent 50. My O will be PQ. And then my adjacent will be 80. Okay, this is the height of the building. So PQ equals to 80 tangent 50. Okay, this will give me 95.340, exactly the same. Round off will be 95.3 meters. Okay, so either way works. See which one you are more comfortable with. Okay, moving on to example 3. Okay, the diagram below shows a vertical tree TB. A, B, and C are 3 points on the horizontal ground, and C is 31 meters from B. Okay, given that the angle of elevation of T, okay, from C, so I go to C, angle of elevation, this is 33 degrees. And the angle of depression of A from T, so I go to T, draw my horizontal line. Angle of depression will be here from my horizontal line to this. This is 42 degrees. Calculate the height of tree. Okay, so actually this one very straightforward. So I will use the triangle on the right side. Height of tree is TB, so this is actually my opposite. Okay, and I have my adjacent, which is given. So I have opposite and adjacent. I can use tangent. So tangent 31 equals to O, which is TB over, this tangent 33 over 31. So TB equals to 31 tangent 33, and this will give me 20.1316. I round off, it will give me 20.1 meter, and this is 3SF. Okay, moving to part B, they want to find the length of AB. Okay, AB is this length over here at the bottom. Okay, so in part A, I already found my O. So over here is 20. This is 20.1316. Okay, so I have another right angle triangle. This one, by using alternate angle, this is 42 degrees. Okay, let me just write that down. Angle TAB equals to 42 degrees. Okay, this is alternate angles. Okay, parallel lines. Okay, so now I have the angle inside. I have a side. So this is my opposite. I want to find my adjacent, which is AB. So once again, I'm using tangent. 42 equals to 20.1316 is my opposite over my adjacent, which is AB. Okay, I bring AB to the other side, and I bring my tangent to the bottom. Okay, so over tangent 42. I type it into the calculator. I get 22.358. And then I round off, I will get 22.4 meters. So this is 3SF. Okay, move on to the next question. So in the diagram, AP represents a building standing vertically at A. The 3 points ABC are on level ground. The angle of depression of B So B from P is 45 degree. Angle of depression of C from P is 30 degree. And B and C are for 53 cm apart. 53 meter apart. Find the height of the building. So this is another real life application question. Let's say you and your friends are standing a few meters apart, and somehow you know the angle of elevation. You can actually find the height of building. Okay, back to the question. So actually when they tell me the angle of depression, I can use alternate angle. Okay, I can find out what this angle is. Can also find out the angle of PCA. So this is 30 degrees. Okay. With that, I need to find AP somehow. Okay, so let me just write down whatever info I have. So using Picasso, I can come up with two different equation. Okay, so using this is my opposite. Yeah, I have my hypotenuse over here. Okay, so tangent. Okay, before I carry on, why do I want to find my hypotenuse? Yeah, this one the height is 53, is given. Right? No, sorry. The height of building, not really given, but it's the same for both triangles. So I'll use O. And then why would I find the hypotenuse? Because I know BC, let me write it. BC is equals to AC minus AB. Yeah, so BC is the 53. Okay, this is AB, which equals to 53 meters. Okay, this is given. Okay, AC is actually the bigger triangle. So let me highlight in blue. Okay, so the bigger triangle, I will use blue color. The smaller triangle, I will use red color. Okay. So AC is the length of the bigger triangle, the base, minus the base length of the smaller triangle, and I'll get 53. So I want to find what is the length of AC, and I want to find the length of AB. Okay, with that being said, I find the smaller triangle first. So tangent 45 equals to O. I don't know the height of O yet, but it's okay. I'll just put it as AP, because that is what I want to find later anyway. Over tangent 45. Sorry, over AB. Okay, because it is my adjacent. Okay, it's not my hypotenuse. Sorry. Okay, so this one will be AB. Okay, I make AB my subject. AB equals to AP over tangent 45. Okay. Now same thing but for my bigger triangle. So tangent 30 equals to AP over AC. I make AC my subject. AP over tangent 30. Okay. Now I have my blue value, I have my red value, my AB and AC, I substitute in. Okay, so BC equals to AP over tangent 30 minus my AB. That's AP over tangent 45, and this will be equals to 53 degrees, 53 meters. Okay, now I factorize my AP out. Okay, both sides have AP. I factorize them out. Yeah, AP equals to, AP bracket 1 over tangent 30 minus 1 over tangent 45 equals to 53. Okay, I bring everything in my bracket over. Okay, so this whole thing, I bring it over. Okay, so I divide both sides by the bracket. I leave AP on my left side. I have 53 over everything in the bracket. So it's 1 over tangent 30 minus 1 over tangent 45. Okay, this, when I turn into calculator, equals to 72.3993. And then I round off, I'll get 72.4 meters. Okay. So this question actually, it is slightly harder because there is no guide and you need to be able to determine your steps by yourself. Okay, but when it comes to this kind of question, always do it step by step. Write down whatever you know first, and then from there you can slowly find out one term by one term. Okay, so in this case, I generally write down what I know first, okay, which is this info that's given, and then I just use my Tuakaso. Okay, moving on to the next example. Okay, so example 5. So everything is written already in the diagram. Show that angle ADC equals to 127.7. Okay, so where's angle ADC? ADC is actually this one. Okay, I know that I can use I can split it into two different parts. So I split it to the red one, I split it to the green color one. Okay, let's find the red one first. I have a right angle triangle. I can just use Tuakaso. Okay, so red color, so opposite 95 is my O, 60 is my adjacent. So I can just use tangent angle ADB equals to O over A. So it's 95 over 60. Okay, so angle ADB equals to tangent inverse 95 over 60. Okay, I bring this slightly to the left. When I type into the calculator, I get 57.724 degrees. Okay, I'll just leave it like that first. And then let me find the green color one. I know that this is a isosceles triangle. So to find the angle, the base angle is just 180 minus 40. Whole thing divided by 2. Okay, this is 70 degree. Okay, so to find angle ADC equals to 57.724 plus 70 degrees. Okay, I'll get 0.724. And then for angles, I will always round off to 1 dp. Okay, 1 dp. Okay, for those who are wondering why angles is always to 1 dp, you can just look at your protractor. The smallest division is 1. Okay, but actually You sometimes can see 0.5 also. So that's how they find out. That's how they determine that it's 1 dp. Just a fun fact. Okay. Find CD. Okay, what is CD? So CD is this one that I highlight in green. Okay, before I can find CD, yeah, I have 3 angles, but I don't know any side. So let me just find one side first. Okay, let me find the side of the base. Okay, because if I have 3 angles, I cannot use any sine rule or cosine rule. So it makes it almost impossible to find. Okay. So to find this purple line, I will just use my Pythagoras theorem of the right angle triangle. Okay. So BD square equals to AB square plus AD square. AB square is just 95. Square plus 60 square. Okay, and then I want to find BD. So I bring my square over, it becomes a square root. Okay, so this is 95 square plus 60 square. Okay, this will give me 112.361. Okay, using sine rule, I want to find CD, so I write it down first. CD over its corresponding angle. So it will be sine 70 equals to 112.361 over its corresponding angle. It will be sine 40. Okay, CD equals to 112.361 sine 70 over sine 40. I type this whole thing into calculator. I get 164.26. Okay, when I round off, this is 164 meters. 3 SF. Okay, nothing here is about angle of elevation or depression yet. Okay, so part C, the land is valued at blah 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 40,000 per hectare. Okay, so I have to find the area first. So area of the field equals to area ABD. Yeah, ABD is my top half. I'm just gonna draw it for you. Plus area of BCD. So this is my isosceles triangle. Okay. So the formula to find is half AB sine C, but since the first one is a right angle triangle, can just half times base times height. So half times 95 times 60. My other one, I'll use half AB sine C. 164.26. So this 164.26 is actually found at the top. Okay, part B. 64.26. Okay, then my other value that I will use, okay, half AB. Okay, so DC have the same length as BC. So it's actually still half 164.26. Okay, I'm using both the common length side and then C will be my 40 degrees. Okay, so this is sine 40. Okay, I type that into the calculator. I get 11521.637. Okay, so value of U equals to 11521.637. So this is actually meter square. So I divide by 10,000 to find how many hectares there are first, multiplied by the price. So it's 40,000 hectare, which equals to 46086.55186. Then when I deal with money, it's always 2 dp. Okay, so it's $46,086 and 55 cents. Okay, 2 dp. Okay, last part. So part T now is the angle of elevation. So it states that a bird is hovering vertically above B. Okay, the angle of elevation of bird A from point A. So point A is over here. Is 18 degrees. So find the height of the bird above B. Okay, so B, it is above B. So it's something like this. Okay, so now I will draw the side view. Okay, let me just ignore the whole view. So now I draw a side view. So this is A. I go all the way to B. So this is the horizontal floor. This is 95. Okay, the bird is over here. So this is above B. Okay, and then from A to the bird. Okay, this one is 18 degrees. This is right angle because it is vertically above B. Okay, then AB is your horizontal floor. They want me to find H. Okay, so I have my opposite. I have my adjacent. It's a right angle triangle. So same thing. Similarly, I'll just use Picasso. Tangent 18 equals to H over 95. Okay, I bring my 95 over. Make H the subject. I get 95 tangent 18 equals to 30.867, which equals to 30.7 meters. Okay. So do you see how we are transitioning to 3D, three-dimensional problems? Okay, so this view over here, it is your flat ground. Okay, and then B, it is actually not on this green field anymore. It is hovering above point B. Okay. If not, that is it for this topic. Okay, just to summarize a little bit, how I remember angle of elevation, I take the elevator up. So that's how I remember angle of elevation is upwards. Depression, when I set, I look down. Sorry, when I depress, I look down. So angle of depression is downwards. Alright, if not, that's it for this topic.